So in this last video for the lecture, we are going to talk about factorial designs. The whole idea of factorial designs start with realizing that effects of any variable are not isolated. They are usually interpretable in a system, and the variables present or influencing the system also influence the effect of each other. So you have an interaction if one factor influences the effect of another factor on the outcome. So the effect of one factor depends on the other factor. Very simple example would be, in most current cultures, the effect of putting on lipsticks on perceived attractiveness depend on the gender of the person who puts on the lipsticks. So the lipsticks would look much different on a man or a woman, for example. Also, another example would be the outcome of a COVID-19 infection on a patient depends heavily on their pre-existing health conditions and their age. So even though we know that the infection has a certain death rate, for example, we also know that the pre-existing health conditions themselves would make a person more likely to die or not on its own. But if you have certain pre-existing health conditions, your chances of would go more than if you just consider one or the other. So there is an interaction between two factors here. So a factorial design lets you not only observe these kinds of interactions in a simple experimental study, but in a factorial design, you actively manipulate both of the independent variables, or if you have multiple independent variables, you are manipulating all independent variables, and this experimental manipulation of these factors allow you a more strong causal inference in the end. So in order to do a factorial design, you must have multiple manipulated independent variables. You would have independent variables that are factors, which basically means that they have discrete levels. They are usually not continuous in factorial designs. So these would be I don't know, different types of treatments or different delivery methods, as we are going to see in the next example. And so when you have these multiple factors and each of them have multiple levels, you would create an experiment where you would have a separate group for each possible combination of these factor levels. So let's see an example, and it will become much clearer. So let's consider that we are assessing the effectiveness of different psychotherapy interventions on improving the quality of life of chronic pain patients. And we are assessing the effects of two types of therapies: acceptance and commitment therapy, so ACT, and CBT. But we also think that the delivery method of the therapy could affect the outcome. So we are also assessing the effect of in-person delivery versus internet-based delivery of the therapy. And we also suspect that these two factors actually influence each other's effect. So basically, we suspect an interaction between therapy type and the delivery method. We think that it is possible that the two therapy types might compare differently under different delivery method conditions. So in this particular case, if we have two levels for each of the independent variables, so ACT versus CBT are the levels of delivery or therapy type, and in-person versus internet-based are the different levels of delivery method. So now we need to create 4 groups for each possible combination of these different levels. So one group would get in-person delivered ACT, another group would get internet-based ACT, another group would have in-person delivered CBT, and the other group, the last group, would have internet-based CBT. So this way, we have covered all possible combinations of these two by two matrix. So this design is called a factorial designs. So the 2 by 2 factorial design. So this 2 by 2 is written up or comes from how many factors there are and how many levels in each factor there are. So the number of the numbers, so how many numbers there are in this formulation, so 2 by 2 has 2 numbers in them, comes from how many factors there are. And the numbers themselves, so come from how many levels are within each factor. So this is how 2 by 2 factorial design is written up or formulated. And our outcome could look something like this if we visualize it in using a bar chart. So here you can see that in-person delivery was always a little bit better than internet-based delivery, and that ACT was better than CBT if you combine the ACT bars and the CBT bars together. So that way you could say that internet-based delivery is, or in-person delivery, sorry, in-person delivery, which is better than internet-based delivery. And you could say that ACT is better at treating this condition or improving the quality of life or enjoyment of life than CBT on average. But we can also see an interaction here. So when we consider internet-based delivery only, we see that ACT and CBT are equally effective. And if we consider in-person delivery, only then can we say that ACT is better. So actually, the comparative edge of ACT only comes out in-person delivery. So the effectiveness, the higher effectiveness of ACT depends on the delivery type. So we have an interaction effect here. So here we could see that this kind of design lets us assess the effects in 2 ways. So 2 types of effects. We can assess the main effect of each of the factors separately, and we can assess the interaction effect. So the main effect means that the effect of the factor, so what's the effect of the change in the levels of the factor if we don't take into account the change in the levels of the other factor. So disregarding the other factor, what's the effect of one of the factors? That's the main effect. And that's what we talked about earlier. So here, if we get the average or take the average of the in-person delivery bars and the average of the internet based delivery bars, and compare them together, we would say that in-person delivery is better than internet-based delivery if we disregard therapy type. And the same could be said, or the same main effect could be formulated for therapy type. So we would average out the gray bars, which represent CBT, the filled up gray bars, the effectiveness of CBT, and these striped gray bars we would average out as well. That would represent the average effectiveness of ACT. And if we compared these two averages together, we would see that ACT is more effective on average than CBT if we disregard delivery type. So we don't take this into consideration. Then we can say that there is a main effect for therapy type, and that's specifically that ACT is more effective than CBT. But there is also an interaction effect. The interaction effect basically means whether and to what extent the one factor influences the effect of the other factor. So how much and whether it depends on the other factor. So factorial design lets us assess both the main effect and the interaction effect of different independent variables or factors. You can get a little bit more insight into how we calculate the main effect and the interaction effect by doing the exercises that I uploaded to the e-learning platform. So just go there and download the PDFs which are called Lecture 7, Exercise 1 and 2, and you will find the tasks. Just follow the instructions there, and you will be able to get a bit more understanding about what is a main effect and what is an interaction effect, and how to calculate them in a very simple way. Okay, so the course generalize this method to multiple factors, not just two factors, but multiple factors, and for multiple levels as well. So in the example that you can see on this slide, we have 3 factors with different levels. So we are assessing a certain drug on, let's say, anxiety, and on decreasing anxiety symptoms. And in this factorial design, we are testing 3 different levels of this drug. So 0 milligrams, so no drug at all, 500 milligrams, and 1,000 milligrams of the drug. And we are also manipulating whether this drug is combined with CBT. And so this factor also has 2 levels, no CBT and CBT. These are the 2 levels. And we are also manipulating self versus therapist administration of the treatment. So we either have the treatment delivered or administered by the patient, him or herself, or a therapist. And so this gives us a 3x2x2 factorial design. So again, there are 3 numbers in this formulation because we have 3 different factors. And the numbers themselves come from how many levels are there in each factor. So the drug amount has 3 levels, the CBT, the presence of CBT has 2 levels, and the self versus therapist administration has 2 levels. So that's why this is a 3 by 2 by 2 factorial design. And if you have multiple factors and many levels for, or multiple levels for the factors, the design can get quite complicated and also very resource intensive. If you want to fill up each of these cells, if you want to have each possible combination, a separate group for each possible combination in this design. So it is also possible to do a fractional factorial design, which is basically if you leave out some of these cells, so you don't have a group for each possible combination, you have some combinations that are not really within your study, but if you have enough cells filled up, you can still statistically extrapolate the expected outcome for those missing cells. So that is a fractional factorial design that is, of course, suboptimal constraints. Then you might choose to use such a design. This concludes the videos for lecture 7. Thank you for your attention.